All right, starting a new chapter. Section 1 of Chapter 6, Evaluate Roots and Use Rational Exponents. It's a big, long, what is that called? Title, but it's super quick and easy. All right, here we go. Hang with me. So you already know that this is a square root symbol, and so this means the square root of a. So you already know what that means. You may have seen cube roots where you've got a with the little square root symbol with a 3, and that means just like the square root said, how many times is a times itself? This says, how many times did we multiply a 3 times? So if you'll remember, sometimes I talk about you bring out pairs for square roots. With a cube root, you're going to bring out triples. So you have to have 3 of that number to come out of the box. The same is true for an nth root. You can put whatever number you want there. A 4 there would be the 4th root, a 5 would be the 5th root, a 12 would be the 12th root. And that simply means something under the box has to be repeated at least, or not at least, it has to be repeated that many times to come out of the box. Let me show you what I mean. All right, so if you have a cube root of negative 216, now here's a trick, all right? If you've got an odd root, you can have a negative number under the root and not have an imaginary number. Because if you have an odd number of factors, you can use that negative number and still get a negative answer. All right. Remember, with the even numbers, we couldn't have a negative under there without an imaginary answer. So in this case, what you're going to do is this. You're going to use your factor tree to find out, well, what are the factors of 216? So start with 216, and let's I know it's even, so 2 times 108. 108 is 2 times 54. Oh, 54 is 9 times 6. 9 is 3 times 3, and 6 is 2 times 3. Huh. Now, those are so small, I don't know if you can see that on there, but we'll make it bigger here. So now, we haven't brought anything out. You're still a cube root, and you're going to have, it's going to be negative. So I would just kind of leave the negative out front for just now. Don't lose it. But what we've got is 1, 2, 3 factors of 2 and 1, 2, 3 factors of 3. And remember, we said with a cube root, we want to pull out triples. So there's a triple, and here's a triple. So now a 2 will come out of the box, and a 3 will come out of the box. So you're going to end up with 2 times 3, and it's going to be negative, so it's going to be a negative 6 is your cube root of negative 216. All right? Did I make that look easy enough? Let's do this one. The 4th root of 81. So the same type of thing. 81 is 9 times 9, and 9 is 3 times 3, and this 9 is also 3 times 3. Whoops, not 9 times 3, that's a 3. So under here we've got the 4th root of 1, 2, 3, 4 3s. And so because we've got a 4th root, we need a set of 4 of the same number, 1, 2, 3, 4. So that can come out of the box because they're all the same. It's kind of like Go Fish. We've got all 4. Oh, we've got all 4. We can take all 4 out. So all 4 3s come out, and it's just the number 3 is your final answer. All right? Now, that's how you work the roots. There's another way to show these roots, and that's with a fraction as an exponent, and a rational number is what they're calling. Remember, a rational number is anything that can be shown as a fraction. So if you have a fraction as your exponent, what's going to happen is this. The exponent, the numerator of your exponent is going to be still going to be the exponent on your base. The denominator of your exponent becomes your root. So a to the m over n power becomes a to the m to the nth root. When we put some numbers with it, that'll make a little more sense. Go ahead and put it in your notes. As I was looking through some of the assignment, your book will also show this like this. The nth root of a raised to the m power. These two mean exactly the same thing. All right? Because if you raise the whole thing, it's the same as if you just raise what's inside. All right? So both of these are the same. So don't let that freak you out when they put parentheses around that. All right. If you have a negative exponent, remember if you have a negative exponent, that flips that down into the denominator because it's kind of like we're dividing that many times instead of multiplying that many times. But it's going to look exactly the same. You're still going to have that a to the n power taken to the nth root, but now it's going to be in the denominator of your fraction. All right? So let's do a couple just to see, well, what are you talking about? Well, let's look. All right. So 125 to the 2/3 power is going to be, it's going to look like this. So you're going to have 125, and 2 is your exponent, and 3 is your root. All right? So that's step 1, to be able to just write it. Okay, you'll have to be able to do that. And then once you've just written it, now you need to go through and you need to simplify it like we did before. So 125 squared, there's going to be 2 of them. Let's see what 125 is if you factor it out. So this looks like 25 times 5. Oh, and 25 is just 5 times 5. So what we could do is this, instead of writing it out, instead of multiplying it out first, what I would do if you've got a squared term under your root, instead of multiplying it first and then factoring it, well, you're just going to divide again. So leave it factored. So what we have now is we have the cube root of 5 times 5 times 5 squared, which just means now we've got another one, right? So 1, 2, 3 factors of 5. All right? So now we look for sets of 3. These are the same and these are the same. So we've got 5 and another 5 come out, and you multiply those together. So your final answer is 25. All right? Easy sneezy. Just follow the steps one by one. Okay. Last one of these, and then we'll go to something else. All right. 8 to the negative 4/5 power. Remember, the negative power is going to put it under the numerator. So you're going to have a denominator here. So you're going to have 8 to the 4/5 power. All right. So now, if we had 5 of them, that would be great. We could just bring the whole 8 out, but we don't. So let's see. I happen to remember. Do you remember that 8 is 2 times 2 times 2? So we're going to have, let's see, 1 over 5th root of 1, 2, 3. There's one of them. 1, 2, 3. There's 2 of them. 1, 2, 3. There's 3. 1, 2, 3. There's 4. So there's one set. Oh, we need 5, not 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's 2 left. So we're going to have to bring 2 out. And then, so we've got equals 1 over the 5th root of, oops, we forgot to bring them out. 2 times 2 is 4 outside, and 2 times 2 is 4 inside. So 1 over 4 to the 5th root of 4. And you know what? I wrote that down. That's why it wasn't, that's why it was so much more difficult than I meant for it to be. Guess what? So this is correct. Now let's work it out the way I meant for it to be, and that way it'll be it'll make a little bit more sense here. Let's change this to the 4/3 power. So keep that and do another one here for me, because that was correct. But I was like, why am I making this so difficult? I wouldn't have made it quite so difficult, because check this out. I wanted to show you this. If you recognize something here, I wanted you to see this. Because if this is to the 4/3 power, now we have a cube root. So go ahead and write another problem. 8 to the negative 4/3 power. What we did was all correct. We're adding another problem. Okay. So now what we can do here is we've got 1 over 8 to the 4th. Well, I know that 8 times 8 times 8 is going to come out, right? If it's to the 3rd power. Let's bring that out. And then we have one more factor of 8. Well, that's 2 times 2 times 2. So that's going to come out. So you don't have to factor that all the way down if you can see some factors that are the same. You don't have to factor that all the way out to all those 2's. That's why I was confused. I was like, I thought I did this so that we wouldn't have all those 2's. So in this case, 8 times 8 times 8 is a cube root. And if we've got 4 of them, then that last 8 is the only one I want to factor out. And now this is a set of 2. So now this is going to be 1 over, well, the 8's come out and the 2's come out. So 8 times 2 is 16. And so my final answer is 1 over 16, which is a neater, a more satisfying answer. All right. The last thing I want to do now is let's take that information that we now know how to evaluate nth roots and exponents that are rational, and let's solve some equations. And I wrote them out. Hopefully I wrote these correctly. Oh my goodness. All right, 6x cubed equals 384. If you think you've got this, go ahead and pause and do it, all right? We're going to solve this just the same way that we did when your x was squared, except now it's a cube. But now you know how to do cube roots, so it's not a problem. So what we're going to do is you're going to divide both sides by 6. So x cubed now is 384 divided by 6 is 64. And so then you just take the cube root of both sides. And now x equals the cube root of 64. So 64 is 8 times 8. And 8 is 2 times 2 times 2, right? And another 8 is 2 times 2 times 2. So you've got 2 sets of 2 that are tripled. So x is 4. All right? And then the last one, x minus 8 to the 5th power equals 100. All right. One more little new thing here. So now x minus 8 to the 5th power equals 100. So this is to the 5th power. So all you have to do is take it to the 5th root. All right. I don't know what 100 is to the 5th root. It's not going to be all nice and neat. And one of the things that you can do is you can use your calculator. And I'll show you when you get to class if you've got if you're just using your phone for your calculator, if you flip it over to its side and you look to the left where those extra buttons come in, your calculator will have a button that says x to the y. I think it's x to the y, is that right? So then what you'll do is you'll punch in 100, and then you'll hit this button, and then you'll hit the 5. And then it should give you 2.5111111 something, or 11 something. Anyway, so what you're going to want to do is you're just going to estimate those, to round them to the nearest 10th or 100th. I think in my answer, I rounded it to the nearest 100th. All right, and then x minus 8 equals roughly 250 or 2.51. So just add 8 to both sides. And so x is approximately equal to 10.51. All right. So look at your calculator, see if you can figure that out. Play around with a couple of them. Play around with some of the ones that we've already done. Do 64 to the cube root and see if you end up with a 4. I think there actually is a cube root button itself, so you don't even have to hit the button and then the number. You can just hit the I think it's x to the cube root, like that. All right. I think that's all I have today. Quick and easy lesson today. Play around with your y to the or x to the y root button and practice with a couple of those. If you want to start on the lesson, you sure can. And I'll see you next time.